Out the in-class exercise for today, just hoping to speed things up. We burned up a lot of time for the quiz, but I do want us to have enough time to go through this rate of return analysis for annual worth. So a couple of quick announcements. First of all, homework 9 is due on Monday. Originally that was scheduled to be due on Friday, and in fact we're still on track with the material where you're going to know everything you need to know to solve that by Friday. So don't delay just because I pushed the due date back. It's just I didn't want to have too much loaded into 1 week. So I'd encourage you to get an early start on homework 9. And then also keep in mind the project. That's due before Thanksgiving, and as the temperatures are getting cooler and you can smell wood smoke in the air and people are starting to think about deer hunting, all those things, Thanksgiving's getting close. So get that project underway. Break it up into bits and it'll be easier. Any schedule or announcement questions before we move on? Okay, here are a couple of variables that, unfortunately, the one thing I don't like about our book. I love our book except for one thing. They overuse the variable I. There's so many different I's that it can be a little bit confusing to keep track of what they mean, and so I want to clarify that for you. First of all, we can talk about interest as an amount of money. And so that variable is assigned capital I in the text. And then lowercase I is when we're talking about interest as an annual rate. So it's a percentage of the original amount over some time period. For example, per year would be common. Now, I star means rate of return. And the way that you calculate rate of return is you do that unrecovered investment balance spreadsheet, and you're trying to solve for some interest rate that makes it all balance out by the end of the cash flow diagram. When you calculate internal rate of return just using the IRR function, that's what Excel is doing in the back of its mind. It's looking at the inflows and the outflows, and it's calculating what's the interest rate that would make everything come into balance. So that's I star. Now, I prime is also an interest rate expressed on a basis of percentage per year, but this is external rate of return, which is what you just did for the quiz. External rate of return takes into account the reality that not every investment can have reinvestment of the returns. In other words, a savings account, you can put your earnings right back into that account, but lots of things you can't, and you have to park that money elsewhere where it's earning an external reinvestment rate. So the external reinvestment rate, along with the rate of return at which cash is generated, both of those come into this external rate of return I prime. Okay, I sub I is the variable that they're assigning to the external reinvestment rate. And some texts assign that epsilon, but unfortunately ours doesn't. Ours uses the letter I again. And then what we did last time in class, the incremental rate of return. So this delta here is talking about the rate of return on the difference in additional cost between alternatives. So last time we were comparing equipment to find out for the item that's more expensive, what kind of return do we earn for the additional expense of the more costly item. And so delta I star is the rate of return on the extra investment. All right, so this slide is in the notes if you're not managing to keep up with copying everything down onto paper. Unfortunately, we have to keep moving or else we won't get into the in-class exercise that we need for today. So I'd invite you to get the definitions from the notes if you weren't able to copy it down just now. So what we're doing today is annual worth analysis combined with incremental analysis. So remember, annual worth is when you're finding out, instead of taking everything to the present or everything to the future, you're finding out how much does everything cost if you paid for it over a number of years with the equal number of payments. So people who buy a car and do it by payments rather than by a one-time cost have a budgetary reason for that. Sometimes it's easier to pay for things on a periodic basis rather than all at once. Well, sometimes we want to compare options in terms of what it would be like on an annual basis, and we also want to know the rate of return between the less expensive option and the more expensive option. So the spreadsheet template that I gave you in that Excel file that's online, and also there's a template on today's handout, it takes you through a method for finding what is the rate of return on the more expensive item, the increment between the cheaper and the more expensive item. The idea back here is that we're going to try and find an interest rate where the two annual worths are equal. That's the mathematical operation that we're going to be going through, and it's an iterative process where we have to try lots of different interest rates to finally get it to balance, but we're trying to find out on an annual basis how the two options compare. So this is the equipment we're comparing in today's example. Two different skid steers, as they're called. One is made by Cat, one is made by Bobcat, and option A has a cheaper cost and it lasts longer. So you'd think maybe at first glance option A is an open and shut case, it's the better equipment. On the other hand, option B, although it costs more, it doesn't last as long, but it has a much lower annual cost and a salvage value, whereas for some reason option A does not have a salvage value. Now you'll notice that these have two different useful lives. And so if we were doing this on a present worth analysis approach, we'd have to use the repeatability assumption and have option B go a second time in order to compare the two. But we don't have to do that if we're doing an annual worth analysis. One of the advantages of annual worth is that it's just already implicit in the process of calculating the annual worth that you can repeat it over again. And so you don't have to manually repeat using the repeatability assumption. Here's the template that I gave you. So what I'd like you to do is, if you haven't already, download and open up that Excel file, and we're going to go through the steps together of translating the template into the solution of what is the rate of return for the more expensive alternative. And here, of the two alternatives, option B costs an additional $5,000. So what we want to find out is, if we go with option B, what rate of return can we expect for that extra $5,000? You know, what does it get us? And then remember, our criteria is always you should do the thing if the incremental rate of return is what? Do you remember what's the decision criteria? If it's larger than the MAR. Right. And so we're going to know whether to go with A or B if option B has an incremental internal rate of return where the incremental internal rate of return is greater than 9%. At the bottom of the page it says that 9% is our MAR. All right, so let me bring up the lights and give you a moment to get that template opened up on Excel. Okay, so the first thing to do is to read through the steps that are given here. It says, first of all, set up a spreadsheet file according to the pattern provided below. Well, that's already given, just for sake of time. Now, step B, enter an initial guess value for delta I star. We don't know what the incremental internal rate of return is, so we'll just say, well, as a guess, what if it's 1%? Okay, we're going to keep playing around with this until we get the difference between these two cells equal to 0. That's going to be our goal-seek objective. Okay, option A is the item that lasts for 10 years, whereas option B only lasts for 5. The initial cost of option A is negative $8,000, and even though cost may imply that that's an outflow, just because of we're going to be combining things together. We're going to leave the negative sign into the numbers just so that it's clear that that is an expense rather than a revenue. Okay, so step C, calculate the annual equivalent of this initial cost using the payment function. So you remember if we say equals PMT, that's going to find an annual value based on either a present or a future amount. And this initial cost is at year 0. Okay, so we want, it's prompting us once we start typing in the equation, the first thing it's highlighting and it says in bold to enter the rate. So we're going to click here and anchor that as the rate, whatever our guess delta I star is, and comma, the number of years. Well, we're going to spread that initial purchase out over 10 years. So I clicked in the cell where it has the lifespan, and then comma, and it's asking, is it a present value, or if we skip over that field, it would assume it's a future value. In this case, it is a present value. The initial cost is in year 0. So I'm going to click in that location, initial cost, and all these other things, future value and type. The fact that it's in brackets means that it's an optional field. And so there isn't a future value I'm going to include with this, and I don't need to tell it anything about type. I'm just going to close parentheses and have it calculate. So the annual equivalent of that, if it is 8,000, is 844. And I'm going to put the negative sign in there because it's switching the sign on me, as Excel sometimes does. And I'd like for it to remain negative since that's an outflow. Okay, now I don't have to type the equation in again. I can just copy and paste. So if you copy, Control C is copy, and then Control V is paste, and it'll calculate the same thing. It'll put the cell in there, except for it's going to move the lifespan to the correct column and the initial cost to the correct column, or you can just type it in again. It's really no big deal. Okay, so now for the annual cost based on the problem statement, we know that the annual cost for A is $3,500 compared to $1,600 for option B. So we'll put that in. Annual cost is negative $3,500 versus negative $1,600. Okay. Salvage value, we'll enter that in. It is 0 for option A, and then it has a $2,000 salvage value. And this is a positive amount because it's revenue that we get for selling the item at the end of its useful life. So if you look on the handout, it's saying now for step D is where we calculate the annual equivalent of the salvage value. So instead of taking this as a one-time payment at the end of the study period, we want to find out the annual equivalent of that amount. So I'm going to do the function PMT again. The rate I'm going to use will be this interest rate, and I'm anchoring it so that I can just copy the formula over into the next area. N is going to be the lifespan. Now, this isn't a present value. The amount that's the salvage, that's actually at the end of the useful life. So I'm going to put in 2 commas so that it skips over the PV field. And now it's looking for a future value. And that's where I'm going to put negative, because it always flips the sign, and then click in the cell location for the salvage value and close parentheses. Okay, so it's 0 as we'd expect since the option A doesn't have any salvage. But when I copy and paste into the location for option B, then I find out how much it's worth on an annual basis to take that over 5 years instead of all at once as a single payment. Now the last thing is just to add up the cost. And you see how it says X plus Y plus Z? I've assigned these variables just to make it easier to keep track of it rather than typing in what they are. So X plus Y plus Z. questions so far? Let's see. What's over here? Okay. Click in here and it'll highlight. Okay. So you need to drag that over so that it's in the amount rather than the label. It's looking. So you just click here and you can actually drag the thing. Well, it has to be back on the formula. Okay. Got it so far? So it's an optimization problem now. You see the difference in amounts between A and B? You want that difference to be 0. So play around with delta I star until the difference between option A and option B, the sum of the annual costs, make it so that the difference between those two amounts is 0. And that tells you the incremental internal rate of return between A and B. You can use goal seek. You can do it manually. Good. Guys already got it. Well done. Okay, so if I go here to data, what if analysis, goal seek, what I want is I want this difference between these two to be 0. And so I want it to change the interest rate. And as soon as I click OK, it'll start humming through lots of different possibilities and quickly find where the solution converges. So it stops when this difference is so small it's within the threshold. So they are correct. They're to the penny. They're equal to the penny. So what this means is that the extra $5,000 you spend on option B is worthwhile, because to get that extra $5,000 you're only paying the bank 9%. But then once you have the better item, you're able to make 12.65% on that increment. And so the conclusion or the interpretation of this example is you should choose option B. Option B is the better equipment. All right, so I'd encourage you to save this file, save the spreadsheet file with the updated numbers so that you have this to come back to as a reference as you're working through the assignment that's due on Monday. If you've got it, that's all I have for you today. We still have 6 minutes left, and so I can circulate around and answer any questions, or if there's anybody who had problem uploading their Excel file during the quiz, please flag me down so that I can take a look at that.